Thank you for that introduction. Do you hear me well? No one hears anything. First of all, I would like to thank the organizers for this conference. It's great to have this opportunity, I think, to meet other people here in Gothenburg, working with data science and machine learning. And I hope this will spur even some more activity within the local community here. And hopefully this conference will be an annual event. So I'm working with data science, and data science, I would say, it's a rather new field, but with roots in, to me at least, with roots into older fields, being mathematical statistics and software engineering. And my background is from mathematical statistics. I got my PhD from Chalmers 3 years ago in 2015, and since then I've been working at Collector Bank, starting together with another statistician, building up this team we now have. And just give you a little bit of my background, because I think what I did as a PhD student was sort of data science, even if it wasn't used as a word back then. I worked at a cooperation between Chalmers, the KTH, Royal Institute of Technology, insurance company Folksam, and the Swedish FSA, Finansinspektionen. And I think what I did in that project is really defining also what I'm doing now as a data scientist. It's about understanding the business, formulating business problems, digging into data, and try to support your results using the data and some theory, and then the most important part, suggest what to do and then actually do it. So in some sense, I've been in the field of data science for almost 10 years, which is, I think, rather long. But this talk, however, will not be about my research. It will be about my time at Collector Bank, where I started 3 years ago, or 2.5 years ago. And it will be a rather personal story. Maybe my team won't agree with me about what I say, but anyway, it's my talk. So the title, Making Data Accessible, is chosen to pinpoint the difference between being a statistician and a data scientist. If you work at a company, you have a problem to solve, you have huge amounts of data, you just dig into the data, you find a solution, and then you're done. But then the problem arises that when you actually want to make this decision, say that you want to determine if someone should get a loan or not, as we often do at Collector Bank, then all the data you can see as a statistician is not available in that IT system taking care of the decision. So that's the basis of the talk. And so there are good reasons why IT systems are not available to get hold of all data at all times. But then your work as a data scientist would be to make sure that the important data is available. And you need some skills to do this. It's not really obvious what skills you need, but I will try to thank you, to mention at least some of them. So just a short background about Collector and what we do. So Collector Bank is of course a bank. You heard that, the name. We can say we have 2 legs, retail and corporate, in 3 countries. So we're mainly doing business in Scandinavia. We have some business in rest of Europe as well, but I would say like more than 95% is in Sweden, Norway, and Finland. In the retail side, we have like regular banking products, consumer loans, credit cards, savings accounts, where our competitors are other banks, and also payment solutions, where our biggest competitor is Klarna, which is also a bank nowadays. On the corporate side, we have a little more diverse set of products. Work with factoring, like buying invoices to increase liquidity for companies. Just regular corporate lending, secured and unsecured. Property finance, debt collection, and debt purchase. So it's a wide range of products and different markets. And as a data scientist, I've been in touch, I think, with all these areas except property finance, which is, there is a good reason for that. There are very few deals, but huge deals. So there is not much to do with the data. It's very much single, getting to know who owns the company, more or less. That's the thing. So, Collector Bank was a rather small company when I started, about 300 employees. And since I started, we've grown by 200, so now we're around 500 in 2.5 years. And a lot of what I'll talk about will be about what happens when a rather small company tries to become a little bit bigger company, and the problems that arises hasn't been there before. So this conference, it says it's about, there is AI in the name, there is also machine learning and data science. You heard in the first talk that machine learning is a set of tools used by data scientists, more or less. So I won't talk about that. It's just a set of tools. And data science on the other side, there is what we do. And you know the definition of a data scientist? Have you heard it before? No? No one has? Then I will tell you. Data scientist, it's someone who works with data and used to be a scientist. So that's the definition. And I think it fits a lot of people here. And so as you understand, there is only one interesting word left in the expression machine learning and data science, and it's data, of course. Any good presentation must have a graph showing the success of your company, and this is the growth of data scientists at Collector Bank. And as you see, it's a monotone function. It's and you also see the defining year of 2015 here. It was a very important year for Collector. It was the year that Collector became a bank. It was the year of the initial public offering in the Swedish Stock Exchange. And also a lot of work was done this year to get the license to store our data in the cloud. So there was work done together with Microsoft and their Azure services. But the most important, of course, was the creation of what would become the data science team. So in 2015, there was one guy working as a statistician. Are you here, Aron? Yes. Yeah, it's awesome. So me and by the end of the year, me and Emma started, and we sort of rebranded ourselves as data scientists. So that's what happened. As you see here, there is 0 in 2014. It's not entirely true, I would say, but it looks better on the graph. So there was one of the creators, or one of the organizers of the conference, Yusuf, was working, and even Aron, I think, started in 2014. But I don't think you call yourself data scientist, right? So there should be 0. That's my definition. As of now, I'm the only original member left of the 3 of us that started in 2015, since 2 weeks. But we are, I have 4 other colleagues, so we're still doing well. And as you see, I said 4, but it says 7 here, 2018, which is my prediction of the end of the year. And it's a good prediction, because we're actually hired 2 people that haven't started yet. So. But what I really wanted to show with you that this is one of the key things you need to be able to do as a data scientist, to deliver your message on a level that even management can understand. So here is what management will see is, this is the future. Extrapolate as you like. But I guess most of you are not here to listen to management strategies. So let's talk a little bit about what we actually do. Of course, we are a bank. We work with credit decisions. That's like the backbone of banking, deciding who will lend who will be able to borrow money and not. And it's about who is creditworthy, and if they're creditworthy, what interest rate to set. We also work a little bit, not as much as we would like to, with fraud identification, and with our debt collection people to recommend action for the administrators, how to handle customers and help them with this work. And we're starting looking into how to evaluate the profitability of different lines of business. We also haven't really started looking into, but what we want to do in the coming time is helping customer service with categorizing emails and improve the functionality of our mobile apps and like a self-service customer service. So that might happen in the year to come. But now in this talk I will give you a little concrete example of something we've actually done. And the journey starts as when I started at Collector, this was the situation that was most likely to happen. There was a huge IT system. Some of you might recognize this. This is our e-commerce system where we're handling. We have a client who wants to sell something to another. Say a company wants to sell something to another company. They have a store online, and they let us take care of the decision of whether or not to let this customer buy and pay by invoice. There is an element of credit risk here, that the buyer are not able to pay the invoice. So this was the setup, and it's still a setup in many places. So there is a huge IT system, some little part where you use statistic, there is some data available, and so on. And it usually goes like this. Some guy who knows statistic look at the data and see, yeah, this is what we should do. Develop a model in R or Python, and then give this model to some developer who knows C#, most likely, and doesn't know any statistics, and implement that model in the IT system. And that, of course, is things will happen during this phase. Getting a statistician talking to a software engineer, trying to explain something. So there will be errors here. It's most likely it will be errors. That's not the worst part with this setup, I would say, anyway. There were some other issues. Some other issues when I started to look into this problem, because we had a model, I wanted to update it, and I had the suggestions of how to do it, and then I quickly realized that we're not able to use the data I want. In here we only have the data of the e-commerce system, but I want to use some other data. say we have data in our factoring system and in our loan system and so on, and those are not connected. And this is a decision that has to be made in less than a second. So that was one thing. The other thing was, even if I could find a good model only using the data in this system, it will take 6 months to get it implemented, because I had to wait for the guys working on developing the e-commerce system to prioritize this. And that's not always the simplest task when there are some calls from the FSA, Finansinspektionen, on other things to fix. So I had a lot of discussions with my former boss and other teammates of what to do in this situation. And we came up with the idea of moving this statistical model out of the e-commerce system, of course. It's as simple as that. Just drag and drop and we're done. Then we get all the control and flexibility of what we want to do. We can do whatever we want and don't have to care about these IT guys. So, awesome. However, we realized that it's not really that simple. First of all, just to keep the same functionality as we had, we have to build an API around this decision engine to get the e-commerce system to communicate with us. We have to make sure that the guys, our colleagues, software developers, sent us the data we wanted, because we didn't have access to it anymore. And we have to add some layers of security around this. But I mean, it's doable. Just hire some guy who knows some Python and some statistics, and let's go. But it sounded like a reasonable task. I think there was the thoughts I had was either we do this and try to make better decisions, or we don't do it, continue forever, do bad decisions. So maybe it's not the most stable solution, but it's, to me at least, it was better than what we had. As you understood, this was what I mentioned was just the first round of things that has to be solved in order to improve something. So as we are a bank, we're heavily relying on information from external data providers, like credit bureaus that have information about companies, of financial statements and tax status and payment remarks and these things. And of course, since we are working in 3 big markets, Sweden, Norway and Finland, we need information from credit providers in all these countries. So to be able to use the external data that was actually also available in the e-commerce system, because they needed some data from them as well, we need to build the integration to these data providers in Sweden, Norway, Finland. And to have a fallback, we needed 2 in each country. So there was some more tasks to solve, but I mean, it should be fine, right? So what we usually get from these data providers is we send a request, send a company registration number, get back a text file in XML format. Then of course, XML is not really useful for computation. So we also need to build parsers for all these to extract the data we wanted. But I mean, it's still fine. But also some other things happened here. Since we cut this part out of the e-commerce system, the guys over here didn't get the data they wanted from here, because they wanted some more data from these reports than we did. So we had to parse out data that we didn't really wanted to have here, just to forward it back to the IT system. It was essentially about who was authorized to sign the contracts within the company who wanted to buy something from our client. So what happened here? We had a statistical model in the IT system working. It's a fine situation is if you were a statistician, don't really caring about making good decision. But we ended up with doing mostly software development with a team of mathematicians. So that's not really what we wanted, right? We wanted to be data scientists, not software developers. So I was at a data science conference in New York City last fall, and I found this book at the Barnes & Noble bookstore. It's, have you read it? You should definitely read it. I have it, I think, if you want to borrow it. You can come to our booth after this talk. It's not really about what you think when you read the title. It's the message of the book is essentially that we're all in sales nowadays. And sales, not in the conventional meaning of the word, trying people to buy stuff from you that they don't really like, but rather the meaning of convincing people about your ideas. It's about moving your coworkers and getting their goals aligned to your goals. And I find that after I read this book, this is essentially what I've been doing. And I think this stresses a key point that you need in a data science team that's not really thought a lot about. I think that data science team cannot operate in isolation. We're heavily dependent on essentially the entire company, but especially I would say the IT department. You need a lot of support from them to do tasks that you know has to be done, but you can't really do them. So what I've mainly been trying to do now is to convince many people in our company that what we really need is a credit report service. Then we can cut out this part of integration, which is mainly an IT task, and keep the things we want to have here in the decision engine. So we get rid of all these sending messages back and forth to different agencies. We keep the part when we get a file and parse it, because parsing, I think, is part of what data science should do. We read, translate, and the data, but not sending files back and forth. That you might not agree with, but that's my view of it. Data science is about data, and text files contain a lot of data. And what's actually good with this is we get rid of not only the integration problem, but also the problem of feeding data back to the e-commerce system, because then they can get it directly from the credit report service and not via us. So it's a rather simple idea, but it's quite powerful. So we started with a situation where we didn't have any flexibility. We moved to a situation where we got the flexibility, but a lot of overhead work doing IT things that we shouldn't really do. And then moving back again to a situation which is more better, where we have the flexibility to make a decision we like, and to update it when we want. But there is still a part missing here, which is what I really wanted to do from the beginning. And this is this credit report service was only about getting external data, right? But we still haven't got access to the internal data, the data we have in our own systems. So say that a request coming in from the e-commerce system, someone wants to buy something, and we have this company who wants to buy, They also have loans. They are in our factoring system, maybe in the debt collection system as well. Then we need a new service which take care of this. And this is the future. We are not here yet. But my next selling task is to convince our organization that we need this one. We need some support from the IT to build this. And that should be exclusively for us, so that we can get all the data we want from the companies that's available internally and use it for decisions in real time. And when we reach this, I would say we are done.
Part of the sales pitch, right?
So, and this is, of course, this is the goal. Can anyone guess what it looks like at this moment? It's more like this. So we have still have statistical models implemented in all our systems, more or less. So this is rather accurate, actually, what it looks like. So we have statistical models implemented some places. We have some decision engines that still have integrations. We still have some external platform that do some things. Yeah, it's a mess, but we're getting there. I forgot to mention one thing here. I think here. This credit report service will also solve some other problems that we have in the company. Because if all the systems start to use this, we'll gather all the information we have from external reports at the same place, and we will save some costs on getting multiple reports. It will also be much simpler for us to, you may have heard of the GDPR, the new law about personal data. There is a lot of information, personal information in these reports, and if we gather them at the same place, it will be much easier to purge them or get rid of sensitive information. So this will actually solve other business problems as well. And of course, sorry. So I mentioned some of these things during the slides. What competences you really need to build a successful team. I guess that the first two are not that surprising. Maybe not the third either. But I think the fourth one is one that's not really thought that much about. And it's something that you really can't do if you are by yourself. You need to have people doing a lot of work first so that you gain trust within the organization, so that people will listen to you. And of course, not all members in the team must have an equal amount of all these skills, but need to be, I guess the first one is difficult to get rid of, but maybe the second, third as well. But the fourth one is, the fourth one, I guess, is not needed by everyone. But the key point to take away from here is that a successful data science team cannot work in isolation. I've been mainly talking about the IT department here, but what I find most interesting in working at Collect the Bank is that I think I've been in touch with pretty much all departments. We're working with the credit department a lot, working with the collection, with the product developers, who work with the law. So you get to know more or less the entire company. And I think this will be the setup for anyone working as a data scientist is in a more traditional business, where your product is not directly linked to some machine learning algorithms like self-driving cars. We're working with more difficult task in determining whether a person will pay a loan or not. You know, everyone can drive a car, but a lot of people cannot handle money. So Um, I said I should only talk about data, but I think I should mention some of the science as well, science part as well. And I guess you all want to know what's really inside this decision engine. And the answer is that there is not that much inside actually. It's what some people call a good old-fashioned AI. So when you start this, the most important thing is to get the flow working, so that actually data passes through this point and is saved and stored in a good way. Because when you start with a new product, for example, you don't really know what to do. But you have to make sure that it moves through the decision engine so that the data gets stored exactly as it was at the point of decision. And that's like the basic of all statistical modeling. So you do this, and then usually you rely on some external evaluation. If you want to sell something to a company, you can get a rating from a credit agency. Then you can use this in the first round. So just get all the data, store it, plain text file to get from the credit agency. You use their external rating, and then you just go on until you have gathered enough responses. So this is a rather slow business. If you sell something, then there is at least 30 days before you expect someone to pay anything. So it's not really updating every second, doesn't really matter. So you implement some simple rules, wait some time, and then when you have enough data, you start to do the modeling, and then you can implement your updated model. And the reason, of course, why I wanted to get this setup is that you have to gain control of this decision engine and the internal data service in order to be able to update your model as you like. And of course, get access to the data. But so this is the flow. We're not really. Usually, we've started a lot of products. We built like first version, implemented the simple rules, and now we are, I would say, here, waiting. And I guess in a few months we'll continue with the modeling. But to sum up a little, this conference contains the AIs, and you heard about AI systems before. So what you really should do when you have started this is that you should prefix all your models with machine learning. This is also for communication with management. And then you automate your update procedure, and you call it an AI system, this decision engine. And then you're done. Then just sit down and wait for more conference invitations. And I think that in some sense it's true. It really is an AI system, because what it does is what an intelligent person would do in this situation. You gathered all the data available about this company. You try to make the best decision possible. You wait for responses, and you update your expectations. So in some sense it's AI. If the definition is, as you heard in the first talk today, if the definition of AI is ability to make decision on a human level, I think it's correct. But we're not really there yet, but maybe in a few years. So I hope you got something out of this talk. I tried to make it a little personal about my journey at Collector Bank, and the way we try to solve things, and what may happen, and how to continue from a situation that's not really what you wanted. So thank you.